Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do three-sum lead code problem, and it is a very interesting problem. If we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Apple, Facebook, Uber, Bloomberg, Google, Tesla, ByteDance and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums and we need to return the triplets. Now we need to return the triplets such that the sum of all of those triplets is actually equal to 0. And we are also given the definition that the elements has to be unique. So I, j and k is supposed to be the triplets, then they should not be the same. They should be different values. We are also told that the answer set must not contain any duplicate triplets. So this is an additional set of complexity that we will have to take care of. Now let's try to understand this problem with a couple of examples that are provided over here, and I have actually broadened these examples. So let's try to understand them. So suppose this is the input array nums we are given. We need to find the triplets such that the sum of each of all the triplets is equal to 0. So if we see that in this example, we can actually find the sum of these three values to be 0. So first of all, we are going to add these three entries into our answer, that -1, 0 and 1. This triplet equals to 0, so we can add that to our answer list. A second triplet we can find is the value -1, again -1 and value +2, because -1 plus -1 plus +2 is also equal to 0. So again we can add it to our answer set, that 2, -1 and -1 as the answer. And now apart from that we cannot find any more triplets, so this is the only answer we are going to return. One critical thing to understand over here is that this -1 is actually using 2 times in 2 different answers. That is perfectly fine, but we cannot have an answer where we already have the value like -1, 0 and -1, and again we have the value -1, 0 and +1. This should not be the answer. So this is one of the conditions that is given. Second condition is that all the values of I, j and k has to be unique, so they are located at unique positions, because we cannot use the same value again and again. We cannot do something like 0 plus 0 plus 0 equal to 0 and return that as the answer of the triplet, because in this case we only have 1 0, not 3 zeros. So just keep all of these things in mind. If we take a look at the second example, over here we actually do not have any pair that equals to 0, right? So in this case we are only going to return an empty array as the answer, and basically this is what the problem is asking us to solve. Now there can be two potential solutions for this three-sum problem that we are trying to deal with. First solution is actually a two-sum problem solution. That is also another LeetCode problem where we use hashing to generate the solution for this two-sum problem. Second solution is two-sum 2 problem where we actually use 2 pointers to come up with that solution. And in this case we are going to see that how using hashing we can solve this three-sum problem, or how using 2 pointers we can solve this three-sum problem, because both of this concept can be useful. We can choose either one of them. Now I'm going to show you the theoretical knowledge of both the problems, but I'm only going to show you coding for this two-sum 2 problem. Let me know in the comments if you want to see the code for this two-sum problem as well, and I can show it to you. Okay, so first let's see that what is going to be the optimal solution using the solution we used in the two-sum problem. Now, if you want to know more about two-sum problem, you can check out my video over here, and that is going to give you much more clarity. Okay, now let's get back to our question. So if we suppose this is the original input that we are given, and we are trying to find a set of triplets that sum up to 0, right? Which means we are trying to find three different values where I plus j plus k is equal to 0. Okay, that is the whole idea. The technique we are going to use is that, okay, suppose this is the first value, right? Suppose if we consider I is equal to -5, once that is done, what we will have to do is we will have to try to find that if j plus k is equal to +5, if that exists inside this remaining array, if that is the case, then we would actually have a triplet called I plus j plus k that sums up to 0, because I is equal to -5, j plus k is equal to +5. And now we simply need to see that inside the remaining array, do we have a pair j plus k that is equal to +5? And that was actually the original question for this two-sum problem. So that is how everything is linked internally. The idea is, okay, that we can find it easily using a hash map or a hash set, and then we would be able to get this answer. The problem that would come in this case is that because we are trying to avoid duplicates, And what would happen with this approach is that, okay, suppose if we consider I is equal to -5, right, we would actually have an answer where the values of -5, 0 and +5 exist as one of the answer, and we are able to generate this. Okay, so now we are able to say that, okay, this -5 we have already taken care of and we found the correct answer. But if we look somewhere inside the remaining array, we would also find another -5. So when we try to repeat the same logic, basically even for this -5, we will also have the I is equal to -5, and we will try to find j plus k is equal to +5. Then again we would have another answer that also looks like -5, 0 and 5. And remember, these is going to be the duplicate value that we are trying to avoid. So in order to make our lives easier, what we can simply do is, if we take this input array and if we sort this input array, and because if we when we sort this input array, we are going to have the same looking values right next to each other. So we can only have a condition that the moment we find out that two adjacent values, they are same. If that is the case, that if we find the two adjacent values to be the same, then we are simply going to ignore that case and move on to the next value. Okay, so now after this whole explanation, let me clean this up a bit and create the sorted array. So now we have our sorted array, right? Now we will try to see that what could be the potential I, j and k values. Now based on the I value, we will also have to determine that what should be the j plus k value, and based on the jth value, we will also have to determine that what should be the kth value, right? That is how we are going to do the things. So first let's try to see that if I is equal to -5. If I is equal to -5, we will have to find j plus k is equal to +5. If we have to find j plus k is equal to +5, we will try to start iterating over this remaining array. Again, we are going to create a hash map or a hash set over here. So let's create a hash set first. Okay, now we are going to start iterating over all the remaining values. Okay, so suppose this value is -5, so we'll try to consider j to be -5. If j is equal to be -5, then k has to be +10. And now we are trying to see that, okay, we'll see that if this k is equal to 10 exists. If that is the case, we will return that. If it does not exist, we are going to add that value to our hash map. Okay, so because k is equal to 10 does not exist, we will have to add all the values to our hash map. And remember, there is a property of a hash set where it does not exist duplicate values, so we will only have unique values inside over here. So since j is equal to -5 didn't work, we'll try to see that whether j is equal to -3 works or not. So if j is equal to -3, then in that case we will need the kth value to be +8. +8 also does not exist, and we can look that up immediately because of this hash set, right? Now we will try to find another value. Okay, so if that didn't work, we will try to see that whether j is equal to 0 works or not. Okay, so if j is supposed to be 0, then the value of k has to be +5. Okay, that we can look up immediately, and we would be able to find that k is equal to +5 already exists inside our hash map. So immediately we found that we are actually going to have an answer list where we are going to populate the values of I, j and k we found. Okay, so we are going to add the values -5, 0 and +5 immediately. Now we are going to repeat the same process for all the remaining values, right? So, and for every single value, we will also have to create the new hash set and new I, j and k values. So we will empty this one. Okay, now the new I value is actually -5. The thing is, this is a trap because we already had a value -5 that we already iterated over. So we will not have to use this one, and that is how we are going to avoid duplicates. Now suppose if next I value is -3. Okay, so if I value is -3, then j plus k has to be +3. Okay, so if j plus k has to be +3, let's see that what could be the potential remaining j plus k values over here. Okay, so over here currently jth value is 0. So if jth value is 0, then kth value has to be +3. Okay, so we'll try to see that inside the remaining array whether +3 exists or not. +3 does not exist, but that is going to help us fulfill our hash. So we are going to add all the entries to our hash map, and we couldn't find k is equal to 3. So now we are going to try the new value of j is equal to 0. So again, because this 0 we already consider for j, we should not be considering this 0, so we can just simply jump over. Okay, so now next value is j is equal to 1. If j is equal to 1, we will try to see that whether k is equal to 2 exists or not, and k is equal to 2 already exists, that we can clearly see over here. So because it exists, we are actually going to have j and k values properly set up, and we are also going to add one more triplet to our answer, that is -3, 1 and 2. Okay, now we can ignore this one. Okay, now current ith value is 0. Okay, if ith value is 0, then j plus k has to be 0. Okay, so now we will try to find j plus k to be 0. Now inside the current method, okay, Now this next value of j, potential value of j, this is the 0th value. So we'll try to add this value, and by the way I forgot to clear the hash, but it would be cleared. Okay, now if j is equal to 0, then k also has to be 0. Okay, so currently k is equal to 0 does not exist inside the remaining array. So because it does not exist, we will try to jump on to the next value of j. If j is equal to 1 can work or not. So if we try to put j is equal to 1, it is definitely not going to work, and we won't be able to find a pair j plus k is equal to 0. So I is equal to 0 is also not going to work. Because I is equal to 0 not going to work, and we have already taken care of this 0, so which means we don't have to see for this 0. Now we will try to see that whether I is equal to work or not. But the question is, do we really want to check whether I is equal to work 1 is going to work or not? Because inside the remaining array, all the values are actually going to be positive values. So because these values are going to be positive values, j plus k is always going to increase the value of whatever the sum of I, j and k is going to be, because this I is positive. So immediately we can stop our search, and whatever the answer we have found, we can actually return that as the answer. And that is the whole approach. Now, and if we see time complexity, in this case the time complexity is actually going to be big O of n log n, that is to sort the array, plus big O of n square. Why? Because for any single ith value we will have to find j and kth value, which means for every single one of them we will have to iterate over the entire list of all the arrays. So that takes like big O of n square, and that is the best we can do. If we see space complexity is also going to be big O of n, because for this sorting operation it takes big O of n time, and plus we are also creating this hash, so that also takes big O of n space. Okay, now we will try to see that what is going to be the optimal solution using the 2sum2 problem. Now if you want to learn more about this problem, you can check it out my video over here, and this is a very good explanation for that. Now we are going to use the same example as the input, and as mentioned for the reasons explained before, basically we are going to use the sorted array in this case as well. So from this original input we are actually going to create a sorted array first, so that is going to help us avoid duplicates. Now the again idea is that currently we are going to consider the one value to be I. Okay, so suppose we are going to consider I is equal to -5. If that is the case, j and k value could be potentially possible, where j plus k is equal to +5, right? And inside this remaining array we will have to find the +5 value. So what we are going to do is we are going to initialize couple of variables. So first is going to be left pointer, and second is going to be right pointer. Now every time we are going to do left plus right. If left plus right is equal to 5, then basically we are good, our life is set, and we can simply add it to our j plus k values. If that is not the case, if we somehow find that left plus right is actually greater than 5, if that is the case, then somehow we will have to reduce the sum of this left plus right. How can we reduce the sum of left plus right? By shifting this right pointer on the left hand side. Why? Because all the values on the left of this right pointer are actually less than whatever this right value we had. And if somehow we identify that okay, this left plus right is actually less than the answer 5, if that is the case, we are going to update our left pointer to go one step on the right side. So then we would be able to increase the sum that we are trying to achieve, and that is how we would be able to generate the correct j and k values. So let's try to see the approach in action. So suppose currently the ith value is equal to -5. Okay, I is equal to -5, j plus k is equal to +5 we are trying to find. Okay, so once we have the j plus k value we are trying to find, we are going to initialize two variables, left and right. Okay, so currently our left pointer and right pointer, we are going to be concerned with that, and we are also going to be concerned with left plus right sum, and that is referring to whatever the value we are trying to find. Okay, so currently the target value is 5. Okay, now the current left position is -5, current right position is +5. So left plus right is equal to 0. 0 is actually less than -5. So because 0 is less than -5, we will have to update the value of our left pointer to go one step on the right. So now the current left pointer is -3. -3 plus 5. So if we do -3 plus 5, the value we get is 2. 2 is still less than 5. So because 2 is less than 5, again we are going to update our left pointer. So now the left pointer is at 0th position right over here. And currently the sum we are going to get is that okay, this is 0, this is 5, so 0 plus 5 is equal to 5. So currently left plus right is equal to 5. 5 is exactly what we are looking for based on this remainder value we have created. Okay, so now this left pointer can be assigned to this j value, and right pointer can be assigned to this k value, and we can actually populate our answer. So inside our answer, we are going to have the first entry called -5, 0 and +5 as one of the answer. Okay. Now we are done with taking care of this -5. So now we'll have to take care of this another value. But again, same thing, this value is also -5, same as the previous value. So again, we are going to ignore this case as well. And now currently our I is going to be -3. Okay. So now if we put our I to be -3, our j plus k sum has to be +3 in this case. Okay. So j plus k has to be +3. Again, if j plus k has to be +3, we will also have to update our left and right pointer. So currently left pointer is also going to be at the position 0, right is going to be position number 5. Okay. And we will also have to update this value as well, that this has to be 3. Okay. Now currently 0 plus 5 is actually 5. 5 is actually greater than 3. So because 5 is greater than 3, we will have to reduce the value of our right pointer. So currently our right pointer is going to come over here. So now the right pointer value is actually 2. Okay. So if we do 0 plus 2, 0 plus 2 is actually going to be 3. So 3, sorry. So now if we do 0 plus 2, 0 plus 2 is actually going to be 2. 2 is now less than whatever the value of 3 is. Because of that, we will have to update our left pointer to go on the right side. Now the moment we do that, okay, this value is also 0, same as the previous value. So because of that, because we have already calculated this 0, we are actually going to ignore this 0 as the left pointer, and our left pointer is going to come over here. Okay. So now the value of our left pointer is actually 1. So 1 plus 2. So 1 plus 2 is actually 3, and 3 is what we are looking for, that we already find the answer. So we are also going to populate the values of left and right over here, and inside the answer we are going to have one more entry called -3, +1 and +2. Okay. Now okay, now we have taken care of all the cases. Now again, this value I is equal to 0. If I is equal to 0, we will not be able to generate the answer, and now in this case I is going to be 1, so that is going to be the positive value. So because of that, we are actually going to break out of it, and simply whatever the answer we have found, we are able to return that as the answer using this 2-pointer solution. And even for, if we see the time and space complexity, in this case the time complexity is also going to be big O of n square plus big O of n log n. Why? Because we will have to do the sorting operation. If we see space complexity, the space complexity is also going to be big O of n. That is going to depend on the implementation for the sorting we are using. So that is how we are able to generate the solution. If you see, in this case we are actually not using any additional hash set, so that is a plus benefit in my opinion. And if you show both the approaches in any interviewer would be like more than happy with you. So first of all, we are going to sort the given input nums, and we are also going to create a new variable called result to store the list of lists that is needed over here. Now we are going to run a for loop across the given input nums. Notice inside the for loop, we are only running it up until the point where the value of nums of I is actually less than 0. And the moment it gets greater than 0, there is no point in continuing with the loop. So we just simply ignore that. Now inside the loop, we are actually going to call our toSum2 function, but for that we actually have a couple of conditions that we are going to take care of. So first condition is that if the given value of I is equal to 0 or the starting position, then we do it, or we check that whether the two adjacent values of I and I minus 1 are the same or not. If they are not same, then only we call our toSum2 function, otherwise we ignore that particular entry. Inside the method, we are going to call the toSum2 method, where we are going to pass in the value of the given input integer nums, the current ith position, and the result variable. And basically that's it. Once this for loop ends, basically with the help of this toSum2 method, our result should have been populated, so we can simply return the result. Now it's time to create the new toSum2 method. First of all, we are going to initialize two pointers called left and right. Now we are going to have our while loop, that while left is less than right, we are going to do some interesting things. First of all, we are going to have a variable called sum that is going to calculate the current total sum. Now we are going to check that if the given sum, if that is less than 0, if that is the case, we will have to increase the value of the left pointer. Else if we are going to check that if the given sum is greater than 0, if that is the case, then we will have to reduce the value of our right pointer. And if both are not the cases, which means our current sum is exactly 0, so first of all we are going to add a new entry to our result variable that we have created. After adding the values to the result, we will again have to update our left pointer until the point that whether the two adjacent values of left pointer, they are same or not. Basically that's it. This should have taken care of all the scenarios, and this should be working. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently.